Hello everyone, so today we as candidates for World Science Innovative Science Project Olympiad from Chulabhorn Science High School, Pathum, Thani in Thailand are going to present you to our project, which is development of fuel briquette from pyrolytic carbon black leftover from West Thai pyrolysis to be as a source of energy in power plant to replace the use of coal. The organizer of this project is Chitipat Kontongvattana and Naruephat Yajai, and our project advisor is teacher Kontongvattana. Other than that, we categorize this project to ER category or renewable energy. Industrial plants and power plants use coal as a primary fuel due to the ability to generate electricity continuously for 24 hours. Other than that, the fact that the price of coal is one of the cheapest fuel in the market led to the use of coal as an energy tend to increase every year.
But coal causes a lot of carbon emission and micro pollution, which is the main factor of climate change and global warming. So, to actually solve the problem as a threat to the future, we lead us to search for substance that can replace the coal. Which criteria of this substance has to high heating value, cost low pollution, and not expensive. After many hours of research, we found that waste of Thai pyrolysis has surpassed all of the criteria, but it has one effect, which is it can cause high pollution. But after we did research again, we found that if we treat the pyrolytic carbon black with formula of hydrochloric acid, it can reduce the ash and sulfur content to effectively at 90%. Surprisingly, it can also increase heating value of the carbon black as high as 30 megajoule per kilogram, which is so much higher than coal that we use in the plants. After that, we obtain the rigid pyrolytic carbon black. We want to make it easier to transport or use, so we decide to buy it with a Kasawa stat at 9:1 ratio since it has high heating value and hard to break, and it is a feature of our process. It is the summary of our process to create the innovation. Following all the process, we want to know the property of it, so we tested it and we found that this innovation could be the answer of the problem because it has heating value of 30 megajoule per kilogram or lower than standard condition 25%. Sulfur content of under 0.7% or lower than standard condition 63.24%, and as content of under 0.5% or lower than standard condition 85.96%, which makes it so much better than normal coal that we use today.
There is still one remaining question that others want to know: if our innovation can compete with other innovation in the market, or if it has market potential. So we analyzed the cost and our competitors, and found out that throughout the process, the price per ton is $64, which is very low compared to the market. Besides that, this is also has high potential, as you can see in this graph. The x-axis represents the efficiency and y-axis represents the cost. Below left-hand side is normal coal, which we usually found at coal power plant, and in below right-hand side is anthracite, which is very rare, and top of the right-hand side is our innovation, which is both efficiency and cheap price, which makes it very suitable to be source of energy in the future. And we also create business model and the market validation, which the result is satisfactory for us. To summarize this innovation is good for environment because of lead ash and sulfur content. Create less waste because we upcycle the carbon back to high quality briquette. And the last, this is worthiness and have very cheap price compared to the normal coal. Last importantly, this also following the SDGs, all Sustainable Development Goals of UN in 7 Goal, 9 Goal, and 12 Goal, which is all very important. Thank you for your attention to our video, an opportunity for us to present involved innovative science project Olympiad. Thank you for your listening again and goodbye.